Supplemental math videos from Circle Christian School.
Measurement. How long, how far, how much? Measurement may not make the world go round, but it will tell you how big around it is. We have our customary standard measure, that's American measure, and the metric system. We are going to give a quick look at both and practice converting within the two. Start your note page off with, of course, a little tabby, and the concept will be measurement. I made a little number line as the symbol here. Customary American standard measure actually comes in three different categories: length, how long; mass, how much does it weigh; and capacity, how much can it hold. We're going to start with length. 12 lines back in its day represented 1 inch. Oops, forgot the I. 12 inches equals 1 foot. 3 feet equal 1 yard. 5,280 feet equal 1 mile. 1,760 yards is also 1 mile. If you were watching the Olympics, you saw people run 440 yards, the 440, and that is 1/4 of a mile. And half a mile is 880 yards. So the 880. When we talk about weight, 16 ounces equals 1 pound, 1 lbs, or 1 lb. If it's more than 1, then it's lbs. And 2,000 pounds equals 1 ton. The one that seems to be the most confusing is changing within our capacity or our liquids. That is actually a little bit different than all the other measures here. So what I do is actually make this very giant G. You may want to use half of a sheet of your paper to make this giant G. And inside the giant G, you're going to put 4 rather large Q's, like so. Q's, of course, stand for quarts. Now it's nice to use another color for this, and I am going to use blue. And you need to put 2 rather large P's inside here for each one. That stands for pints. There are 2 pints inside of every quart and 4 quarts inside of a gallon. The next one I'm going to do is cups. And inside of every P, what I'm going to put is 2 C's. There are 2 cups inside of every pint. So therefore, there are 4 cups in a gallon. And 4 times 4, 16 cups in a, I'm sorry, I did say that wrong. There are 4 cups in a quart, and there are 16 cups in a gallon. And if you've got the space, inside of each one of the little cups, you're going to put a little 8, because there are 8 ounces inside of every cup. And as long as you remember that there are 8 ounces to every cup, you can pretty much figure out how many ounces are inside a pint, inside a quart, and inside a gallon. And you can kind of convert back and forth by just remembering this picture of the giant G. Okay, I would like you to actually turn to the one page that has the metric chart to it. I know it's a little bit dark in that gray there, so if you can use some sort of different colored pen to fill things in, that will kind of help be able to see it. In the metric chart, I like the metric system of measuring things a little bit better because it breaks everything up into tens, and that's actually a little more of how we count. If you think of a place value chart, then it's exactly the same. The second thing that I like about it is that you only need to really learn 9 things. You need to learn the base, so 3 down, and you need to learn 3 to the left and then 3 to the right. As long as you know those 3 3 3s, then you can pretty much jump your way back and forth within the metric system without doing any type of unit measurement. Now, at the top here, what I'd like you to fill in is the values. So I'm going to start right in the middle here with my bases, and they're of course worth 1 unit, 1 base. We have 3 measures that it's broken up to: length, mass, and capacity, just like the other. The length is called a meter, and it has an abbreviation of M. Now, a meter is basically about 39 inches, but if you look at any doorknob, you'll see that from the floor to the doorknob, it is very close to being 1 meter long. For weight, we use grams. You'll see that a lot on the cereal boxes and other types of food measure mostly, but even at hospitals when weighing babies or weighing people, a lot of times they will do it within the metric system here, and that's a G. Capacity was probably our first exposure to the metric system, and that's kind of because Coca-Cola came out with that 2-liter bottle. You're definitely too young to kind of remember that. But now we're pretty used to it because, you know, we get the 1-liter water bottles and et cetera, et cetera. The liter is something that actually gets used a lot in chemistry when working with liquids, and grams you'll see a lot also in chemistry or any type of medical type of thing. All right, so I'm going to go across the top here to the left and fill in the values. And like I said, it's just like your place value chart. Excuse my cute little sounds that happened here. I forgot to turn something off, and every time a pop-up comes up, it just does this crazy sound. So it's one of the crazy sounds that you get to hear when I do recordings. The next one is, of course, we go to the hundreds place, so 100 of the base. And then the last one that we'll be using, there's several after this one that go with mega, giga, tetra, and a few other things, is 1,000. So, for instance, if I was talking about meters with tens, if I was in the tens place, it would be 10 meters, 10 the base, 100 meters, 100 the base, and 1,000. Each one of these have their own little prefix name. For 10, we call it deca. I've seen this both ways with a K and a C, and the abbreviation for it is DA. That's because we have another D, so they use a DA here. The next one for 100 is hecto. Hecto and deca are kind of two rather lost measurements. They do not get used all that often. And then the last one, something you're probably very familiar with, a kilo or kilo, kind of depends where you're from. And we're used to using that one because we run 5Ks. And 5K is approximately about 3.4 miles. So that's the other 3 that you need to know. You need to know 3 down, the base, meter, gram, liter. And then you have to know the prefixes for 10, 100, 1,000, deca, hectare, hecto, and kilo. Now what we're going to do to the right here is actually break 1 up into parts of 10. The first one is 1/10, or as a decimal, 0.1. The next one is 1/100th, hundredths place, and that's 0.01. And then we have the thousandths place. Always have fun trying to put that S behind the THs. And that's 0.001 in its value. And they have prefixes also. The first one is deci, which is just D. Centi, think cents, which is a C. And then we have that silly little milli, which is an M. Now we can fill out the rest of the chart by just using the abbreviations. So running along meter here, we have kilometers, hectometers, decameters, decimeters, centimeters, ones that we use quite often in measurement, and millimeters. These are the two that you will generally see when using your metric measure. For grams, we're going to have kilograms, hectograms, and decagrams. And then our decigrams, centigrams, and milligrams. Likewise for liters, kiloliters, hectoliters, I use a capital L. That way it doesn't look like a 1 there when you're talking about liters. Centiliter and milliliter. Very good. Now again, the whole thing is, you know the whole chart. As long as you remember place value and you remember 3 things down, meter, gram, liter, 3 things to the left, kilo, hecta, deca, 3 things to the right, deci, centi, milli. There's a little mnemonic that you can also use to kind of remember the order of these, and it kind of has this King Henry thing going on, but it's King Henry died by drinking chocolate milk. It's actually kind of a very famous one. So King Henry died by drinking chocolate milk. There you go. All right, let's use our metric chart now. And if you kind of keep it in your head, you can pretty much just do the move. It's all about just moving the decimal. The other beauty of using the metric chart is that it really is about moving a decimal one way or another in accordance to whatever the base is. So as long as you remember that there are so many jumps to get from one place to another and the direction of those jumps, you can work within this metric chart all day long. So the first thing that we're going to do on the page there is change 4.32 centimeters to kilometers. My little arrow means 2. Okay, so what I'm going to do is start at centimeters. It's just kind of like a game board. This is where I'm going to start. And I'm going to count the jumps that it takes me to get to kilometers here, or kilometers, depends on how you say it. And you'll notice that you did 5 jumps. What that means is you're going to have to go the same direction and move that decimal that many times. So what you end up with is 0.000432 kilometers. All right, let's try the next one. Change 0.056 grams kilograms. I'll put it on top there. To grams. And again, I'm going to start with the very first one, which was kilograms. And I'm going to jump until I get to grams. 1, 2, 3. So therefore, I'm going to move the decimal point, same direction, 3 jumps, and that's going to give us 56 grams. See? Easy peasy. 2.0 5 liters to milliliters. I'm going to go ahead and let you try this one on your own and then take a look and see if we get the same answer. All right, so did you get 2,500,000 milliliters? Hooray! Now, with area and volume, the power does make a difference here. Saxon books were famous for doing this. They would give you the picture, want you to find the area, and then they wanted the answer not in the area that you used. They wanted it in a measurement of metric differently. Well, the trick here is actually very simple. That if something is squared, notice the little 2, it just means whatever you jump, you have to do twice. And the same thing happens with volume. Whatever you do, you have to do twice. So if we're going to convert the area of a rectangle from 6 meters squared to millimeters squared, it just means I'm going to start at the beginning here. I'm going to jump to where I'm going. 1, 2, 3, but I have to do it twice because area is squared. 4, 5, 6. So therefore, it would equal 6, 1, 2, 3, 4, 5, 6 millimeters squared. The volume one, likewise, where we have 20 kiloliters cubed, and I know you've always wondered how many milliliters cubed that would be, going from very large to, or going to a regular size, going to something that is just gigantic in its measurement here. That would do the same thing. We would start with kiloliters, count our jumps, 1, 2, 3, 4, lost my line, 4, 5, 6. I do that 3 times, so that means 18. And so I have to move my decimal 18 places. In this case, I'm going to have to add 18 zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oops, too many. Sorry. Let me use my whiteout. I'm writing in pen. There we go. So we have something like, scary, scary looking, you know. They claim like maybe like our national debt, but actually our national debt is somewhere inside that area, up around $1 trillion. All right, try the last one on the page and see how you do.